Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of second derivative. So as per the problem, determine the value of the second derivative at the value indicated. State whether the curve lies above or below the tangent at this point. So we are given the function p at w equals w over square root of w square plus 1 at w equals 3. So we have to find the second derivative of the function p at w. So we'll start by finding its first derivative. Now in order to find the first derivative, we should change the form of this given function to make it easy to find its derivative. So there is a radical term in the denominator. So the first step is to change this radical into a rational exponent. So our first step is p at w equals so the radical which represents square root can be changed to rational exponent 1 over 2. Now we can move the denominator to the numerator and that will make the exponent negative. Now we can use the product rule to find the derivative of p at w. So the first derivative, so prime of p at w equals, so as per the product rule, so we start with the derivative of the first term, which is w. So the derivative of w is 1 times the second term plus the first term, which is w, times the derivative of the second term. Now for second term, we'll have to use the chain rule because it has an inner function w squared plus 1 and the outer function is the exponential function with exponent negative half. So we start with the derivative of the outer function and for that we'll use power rule. So we'll move the exponent negative half to the front and subtract 1 from negative half. And now we multiply by the derivative of the inner function. So the derivative of w squared plus 1 is equal to 2w plus 0, but we can ignore the 0. So this is the expression we get for the first derivative of p at w. Now we can simplify this expression. So in the first part, multiplication by 1 doesn't change anything. So we get and in the second part, we can multiply negative half by w. So we get negative w over 2. And when we multiply negative w over 2 by 2w, so the 2's get cancelled out and then negative w times w will become negative w squared. So I can show you the steps here. So first we'll just multiply w by negative half. So we get negative w over 2. So in the exponent, negative half minus 1 is equal to negative 3 over 2. And then times 2w. Now in this step, we can combine w over 2 with 2w. So we can multiply them in the second part. So the first part stays the same. and negative w over 2 times 2w will be just negative w squared. The 2's will get cancelled out. So this is the first derivative of the function p at w. Now we have to derivative of this expression to get the second derivative of p at w. So we start with this, the double prime of p at w equals. So for the first term, we'll have to use the chain rule because there's this inner function w squared plus 1 and the outer function is the exponential function with exponent negative half. So we start with the derivative of the outer function. So as per the power rule, we'll move the exponent negative half to the front, subtract 1 from the exponent, times the derivative of the inner function. The inner function is w squared plus 1. So the derivative is 2w plus 0, but we can ignore the 0. Now we can find the derivative of the second part here. So here we'll have to use product rule because this expression is made up of two functions w squared and w squared plus 1 exponent negative 3 over 2. So we can use the brackets. So as per the product rule, so the derivative of w squared is 2w times the second term plus the first term w squared times the derivative of the second term. Now for second term, we'll have to use the chain rule. So we'll start with the derivative of the outer function. So we'll move the exponent to the front. So negative 3 over 2. And we'll subtract 1 from exponent. Times the derivative of the inner function. And the inner function is w squared plus 1. So the derivative will be 2w plus 0. But we can ignore the 0. So this is the expression for the second derivative. Now we can simplify this expression. So in the first part, we can cancel out the 2's. So negative half times 2w will just be negative w. So the 2's will get cancelled out. So double prime of p at w equals. So we get negative w times the w squared plus 1. The exponent negative half minus 1 is equal to negative 3 over 2. Now in the second part, so minus brackets. So we can move w squared plus 1 exponent negative 3 over 2 to the denominator of 2w to make the exponent positive. And then in the next part, so negative 3 over 2 times 2w will become negative 3w because the 2's will get cancelled out, and w squared times negative 3w will give us negative 3w cubed, and then w squared plus 1, and then in the exponent negative 3 over 2 minus 1 is equal to negative 5 over 2, and then close the bracket. Now we can simplify this further, so we can continue at the top in a different color to make it easy. So let's put the cross sign here. We'll just continue here. So we'll start with, so double prime of P at W. So in the first part, we can move W squared plus 1 to the denominator to make its exponent positive. So negative W over W squared plus 1 exponent 3 over 2. Now in the second part, we can distribute the negative sign into the brackets, and that will change the sign of the terms inside the brackets. So we get negative 2W over W squared plus 1 exponent 3 over 2, and then plus 3W cubed, and we can move W squared plus 1 to the denominator to make the exponent negative 5 over 2 positive. Now the first two terms are like terms because the fractions have the same denominator. So we can combine them. So negative W minus 2W is equal to negative 3W. So this is the expression for the second derivative of P at W. Now we have to find the value of the second derivative at W equals 3. So in this step we can sub in W as 3 in this second derivative. So we get negative 3 times 3. Now we can simplify this expression. So in the denominator, 3 squared is equal to 9 and 9 plus 1 is 10. And in the numerator, in the first term, so negative 3 times 3 is negative 9. And then in the second term, so 3 cube is 27 and 27 times 3 is 81. And in the denominator, so 3 squared is 9, 9 plus 1 is 10. Now we should simplify the terms in the denominator. So for that, I can show you the steps on the side. So let's start with 10 exponent 3 over 2. Now as per the concepts of rational exponents, we can rewrite this expression as square root of 10 cubed, because the 1 over 2 can be written as a square root. And now 1000 can be written as 10 times 10 times 10 under the square root. Now two tens can come out of the square root to the front, and we get 10 square root 10. Similarly, we can simplify 10 exponent 5 over 2. So we know we can simplify the 10 exponent 5 times 1 over 2. Now 1 over 2 represents the square root. So it's basically square root of 10 exponent 5. So which is equal to 10 times 10 10. Now each pair of 10 can come out as a single 10 in front of the square root. So we get 10 times 10 with 10 remaining under the square root, which is equal to 100 square root 10. So now we can do the substitution in the expression for the second derivative, because these simplified terms will make it easy to combine the fractions. So we can rewrite our second derivative as over 10 . Now we can find a common denominator to combine the fractions. So the common denominator here will be 100 square root 10. So to get that common denominator, we should multiply the first fraction in the numerator and the denominator by 10. So we can continue here. So the double prime of p at 3 equals, so we get negative 90 over 100 square root 10 plus over. So in the denominator, when we multiply by 10, so the 10 multiplies with the 10 that's outside the square root. Now we can combine these fractions because they have the same denominator. So negative 90 plus 81 is equal to negative 9. So this should be the final answer for the value of the second derivative at w equals 3. So we have answered the first part. Now we have to state whether the curve lies above or below the tangent at this point. So we got a negative value for the second derivative. So that means the curve concaves down at w equals 3. Therefore, the curve is below the tangent. So this should be the final answer for the second part of this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.